section goes over how we organize data, which is one part of statistics. What we're going to look at is we want to make sure it's understood that it's very difficult to analyze and interpret raw data or make meaningful observations about a group of numbers. So we use charts and graphs to help us visualize data sets and put them into useful context. If you think about what's going on around the world right now with the coronavirus and COVID-19, we are kind of being bombarded with data and information, number of cases, number of deaths, number of recoveries, percentages of mortality or fatality rates. And so if all we have is raw data, just the numbers, we don't have a full picture of the story. One example I've heard was comparing the United States numbers to Italy's numbers at the very beginning in March. And one of the things is if you look at the chart, it's like, oh no, at March 20th, the United States cases jumped way up over Italy's cases. But you have to then start to think about the difference between those two countries. We have a much larger population than Italy does. We had just started to do testing. We have a lot of cases now. And so it's not just the raw data that's meaningful, it's interpreting and analyzing that raw data and presenting it in a useful manner. So one way we're going to look at representing data is just looking at what's called a frequency distribution. And a frequency distribution is a listing of the observed values and the corresponding frequency of an occurrence for each value. So all you're doing is just looking at a list of data and determining how many times does each piece of data appear in that list. So we have an example here where we're going to make a frequency table. We have a group of male students are randomly selected and asked their height in inches. The results are listed below. Use the data to answer the questions. So we're going to first start by making a frequency chart to organize this data. So the data is not given to us in order. So what we want to look for is what's the lowest and smallest value and what's the highest value. Now remember, this is talking about male students' heights in inches. So if you remember, 12 inches are in 1 foot. So if somebody's 5 feet, that's 60 inches. If somebody's 6 feet, that's 72 inches. Just for context, relatability, I don't know. I'm short. I am 64 inches tall. So these numbers are all much taller than my height. Not that that matters. But anyway, what we are going to do for a frequency table is you just take your data you're looking at. So we have height, and then we have number of occurrences, or you could just say frequency. And then you're going to tally for each of these values, going from the smallest to the largest, how many times it appears. So our smallest value in this list is 66. So we'd start with 66. And then it goes all the way up to the highest value is 75. So 66, 67, 68, 69, and I'm actually probably going to have to do this on another page just so we have enough room. So I've taken all of the heights that are possible in that entire range from the lowest to, or the smallest to that tallest, and clearly they are probably rounding to the nearest inch because somebody could be 65.5 inches or 67.8 inches, or in the standard system we actually use fractions, so it'd be like 67 3/4 inch. But what we're going to do is we're just going to use these whole number of values from this given list and we tally them off. So the way we do this is we're first going to look at our first value, which is 72. We're going to come to our chart, and at 72 we're going to mark a tally. Then we have 70 as our next value. Come to our chart and tally a 70. I'm going to keep doing that. You do that on your own and then compare your answer. So go ahead and pause for a moment, fill out your chart, and then compare with mine. And here we have our finished frequency distribution and frequency chart representing this data. So you can see by my tally marks how many times each height appeared in that list. 66 appeared one time, 67 appeared 3 times, 68 appeared 2 times, 69 inches appeared 0 times, 70 appeared 2 times, 71 appeared 6 times. Remember that this bunch right here that I'm circling in blue represents 1, 2, 3, 4, and the slash across is 5. So there's a total of 6. Sorry for the switch in colors, I'm just going to leave it. 72 inches showed up 7 times, 4 times for 73 inches, 1 time, and for 75 inches, which is 6 feet 3 inches, almost a full foot taller than me, would be 2 occurrences. It shows up a number 2 times, the number 2 times. So that is our frequency chart. So one thing I want us to recognize here is that if I counted how many data points there were, there's a total of 28. So when I come and look at my frequencies, when I add all of those up, there needs to be 28. I want to make sure that the number of occurrences, the frequency, the total frequency for all of these data points adds up to the total number of data. Okay. Now we can use our frequency chart to answer some of these questions about that data set. So based on this frequency chart, we can say that the tallest height that we saw observed was 75 inches. And the little quote represents inches. The shortest height that we observed from these 28 students was 66 inches. What's the most common height? Well, that's the height that shows up the highest number of times, which is 72 inches. And the second most common height would be whatever's one or the next to the highest value, which would be 71 inches. The least common height in this range would be 69 inches because nobody reported that height in this group. The total number of heights that we saw was 28. We added them up. We saw that n was equal to 28. Which heights weren't listed? Well, you kind of have to read into this question. So not listed, we could argue that 69 inches wasn't listed because no student reported that. We did include it in our frequency chart because it was within that 1 inch range from 66 to 75, but it wasn't listed as one of the data points. And then we also didn't list any value or height that was less than 66 inches or any height that was greater than 75 inches. And the reason why is because no heights were reported that were less than 66 and none were reported that were greater than 75. So we wouldn't want to start this chart from 0 all the way to like 1,000 because we can't be 1,000 inches tall. And even when you're born, you're not 0 inches tall. So we only want to include the range of values that's viable for the set of data that we're looking at. Which heights showed up multiple times? Well, that's almost every single one of them. Anything that showed up more than once, we would count. So we could say all but 66, because it only showed up once, 69 inches, and then 74 inches. Because 66 and 74 only showed up once, and 69 only didn't show up at all, and so therefore those were not, those heights did not show up multiple times. And then overall, are the students shorter, taller, or in between? So here's my question to you. Can we actually answer that? What does it mean for something to be shorter, for heights to be taller, or to be in between? Well, I already told you that I am 5'4", so my height is 64 inches. Everybody on this list, if they were standing in front of me around me in a room, would be significantly taller than me. I'd be the shortest one in the room. So I would argue that all of these students were tall. But if I were, let's say, 81 inches tall, which is 6 feet 9 inches, I would probably look at this list and be like, I'm the tallest one. These people are short. Okay? And so it's all relative. And so this is not a good question to ask we would not use this data to answer this question because we can't. It's depends on what you're comparing it to. If you were comparing these gentlemen's heights to kindergartners, yeah, they're tall. But if you're comparing them to a professional NBA basketball team's heights, these might not seem very tall. Okay. So please keep that in mind when you're looking at and answering questions with respect to data. Let's look at some terminology related to group frequency distributions. First thing is class, and that's a way that you group data. So sometimes it's difficult to observe the data if it were ungrouped, and so we put groups of the data together to form classes. You'll see groups of data or classes when we make histograms and when you make frequency polygons. And then also there are some rules for developing classes. So this gets a lot of space on here. The classes should all be the same width. Classes should not overlap. So no overlap. Each piece of data should only belong to one class. So data can only be an element of one class. Oftentimes with numerical data, you'll see the classes being a range of values. So something from like 0 to 4, 5 to 9, 10 to 14. Those are examples of classes of numerical values. They're grouped, they're the same width, meaning that so 0, 1, 2, 3, 4 contains 5 total values. 5, 6, 7, 8, 9 contains 5 values, so forth and so on. So they're the same width. There's no overlap. And as long as my data is an integer, it's either going to be in one class or another class. It can't be in two at the same time. So that's what we are talking about when we talk about classes. Look at this example here of some classes 0 to 4, 5 to 9, 10 to 14, and 15 to 19. When we say lower class limit, that is talking about the bottom parts of each of the classes. So that's going to be 0, 5, 10, and 15. When we talk about the upper class limit, that is going to be the high ends of each of the classes. That's going to be 4, 9, 14, and 19 in this example. The class width is the number of values that belong to each class. And we're looking at integers and integral values. So these are the number of integers within this group. So in this case, in this example, my class width is 5 in the example because it's inclusive. So it includes 0, 1, 2, 3, 4. And if you lift up your fingers as you're counting like I'm doing right now, you'll see that there are 5 integer values within that width. Now, we could also have data that has decimal values, and then you want to be very thoughtful about how you create your classes so that in a decimal value gets included in exactly one class without any overlapping, and that each class is the same width. So you got to be careful with that. The midpoint of a class, also called the class mark, is found by adding the lower and upper class limits and dividing the sum by 2. In my example here, I would do 0 plus 4 divided by 2. Well, 4 divided by 2 is 2. I would do 5 plus 9 divided by 2. So 5 plus 9 is 14. 14 divided by 2 is 7, etc. So those are the midpoints of each class. So that's the middle value between the upper and lower class limit. I guess I should do an order. So lower and upper class limit. If I were to look at this on like a number line here, what number is exactly in between the midpoint between 0 and 4? That value is 2. What's number is exactly between 5 and 9? That number is 7. Okay, and then the last part of the terminology is the modal class. And the modal class of a frequency distribution is the class with the greatest frequency. So If you were to look at this as like a chart, and honestly, we can go back and look at our chart for this example. Which one was our modal class in this height example? Well, it's the one, if I look at this, I have kind of this relationship, and the one that's the modal class is the one that has the most frequency, so that would have been the 72 inches in our height example. So modal does not refer to what you might think it refers to. It's referring to the class that has the greatest frequency. So those are the words that we need to know in order to look at these frequency distribution tables and charts that we're going to create. So we're going to make a grouped frequency distribution chart for this data. Now remember, we go from 66 to 75. So I'm actually going to make my class widths by 2. So my first class width is going to be from 66 inches to 67 inches. Then we have 68 inches to 69 inches. We have 70 inches to 71 inches, and then 72 inches to 73 inches, and 74 to 75 inches. And that is our frequency classes, our classes for this example. This as class, and this is frequency. I can use the chart from before or the list of the data again to recognize the frequency of the data that's in the class from 66 to 67. Now I can just count. It's 1, 2, 3, 4. And then from 68 to 69, it's 2. 70 to 71, it's 1, 2, plus 6, that's 8. 72 to 73 is 7 plus 4, that is 11. And from 74 to 75, that's 3. So our modal class in this situation is the 72 to 73 inches. That's the one that shows up most frequently. The next question says to identify its lower and upper class limits. That's talking about this modal class. So the lower limit is 72 inches. The upper limit, which I'm writing in blue, is 73 inches. Identify its midpoint. Well, we would take 72 plus 73 and then divide that by 2. Which is 72.5 inches. That's the midpoint. So that's my answer for right there. And overall, are the students shorter, taller, or in between? Now, again, we kind of run into that issue of like, well, it's kind of all relative. Anna's still short. So all these people are going to be really tall compared to her. But if we're just comparing them to one another, like the group here of these gentlemen, and kind of determining are they on the tall side or are they on the shorter side, because they're modal class and it's a little bit heavier on this taller end, we could say maybe that these gentlemen are a little on the tall side. Now, again, that's all relative. You could always have somebody who walks in and says, no, they're so short, I'm 10 feet tall. I mean, maybe not 10 feet, but maybe they're like 7 feet 2 inches or something. And they might say, yeah, those gentlemen are short. But compared to one another, because our modal class is towards the taller end, and it appears to be slightly heavier on the taller side, we could say that they're a little bit taller. I'm going to continue part 2 of this video with looking at histograms and bar graphs and frequency polygons, so please make sure you watch that second video.